So going back to reserved words and identifiers, our scanner is almost done. The only remaining pieces of the lexical grammar to implement are identifiers and their close cousins, the reserved words. You might think we could match keywords like or in the same way we handle multiple character operators like less than or equal, but not, as you can see. Consider what would happen if a user named a variable ORCID. So the scanner would see the first two letters. Again, we were introduced yesterday with the concept of maximal match, in which those that highest character that match that wins. This is also why we tactically assumed previously that less than or equal scan a single less than or equal token and not less than followed by equal. So maximal match means we can easily detect a reserved verb until we reach the end of what we might instead be an identifier. After all, a reserved word is an identifier. It's just one that has been claimed by the language for its own use. This is where the term reserved word comes from. So we begin by assuming any lexeme starting with the letter or underscore is an identifier. So here, else if is alpha in parameter C, then next line identifier. So this is after if is digit parameter C, then inside this number method. Then after else if is alpha parameter C, next line identifier, then next line else, then next line locks that error parameter line, comma, unexpected character. So this is the same unexpected character. So the rest of the code lives here. So we have private void identifier helper or private void identifier method. Inside is a while is alphanumeric peak method, then advanced method. The next line, add token parameter identifier, closing. Notice how we use a while again and a peak and advance. So here, here is the identifier. So notice how we add that after the locks.error. So it's still case after the ignoring white space. We handle the case of identifier. So using if else, and then a private helper again. So we define that in terms of these helpers. So we define that using private boolean is alpha parameter char C. So here, return C greater than or equal A quote and C less than or equal Z quote, or next line is C greater than equal A quote and C less than or equal capital Z quote. So here and then or C equal underscore. So as you can see, we return here a comparison of C, same C small letter, and then same A, same A and Z small letter, then same A and Z capital letter, and an underscore. So we have an or on this. And then we add another helper, private boolean is alphanumeric parameter char C, next line, return is alpha parameter C or is digit parameter C. So we use three helper for identifier, and we add that after the peak next. So as you can see, we have or, return or, less greater than equal, and or. Inside the is private boolean is alpha char C, and then we return an or as well, which is alpha parameter C or is digit parameter C, which we have defined as a case first in our after the case of handling white space. So that case is an if else if, then that gets identified your working. So to handle keywords, so after that those will handle the As you can see, this is the peak next. So the if current plus 1 greater than equal source dot length, then returns slash 0 next line returns source dot char at parameter current plus 1. So these are the peak next that we have discussed in the previous video. Now that gets identifiers working. Now to handle keywords, we see if the identifier's next sim is one of the reserved words. So we see now if the identifier, again of that variable, is one of the reserved words. If so, we use a token type specific to that keyword. We define the set of reserved words in a map. So again, if so, we use a token type specific to that keyword. Here we have we use a map for all reserved words. So here we would add it in scanner.java again. In class scanner. So static inside against keywords equal new hash map. Keywords that move put end, so we send the end token. We have comma end, and then true comma true token var comma var while comma while. So then after we scan an identifier, we check to see if it matches anything in the map. So after we scan the identifier, notice we scan the identifier before we handle the reserved words. Because, we scan that first, kind of like with advanced, we check that identifier, if it match our existing implementation, or if that character match, even if it's an error, we still advance into it. It's the same with this. So in identifier, so while is alphanumeric peak advanced, the one that we created earlier, we will add this string text equals source that substring parameter start comma current closing next line token type equal keywords that get parameter text semicolon next line if type equal null type equal identifier closing then next line add token parameter type. So if so, we use that keywords type, otherwise it's a regular user-defined identifier. So if it's part of those token we define, therefore it is part of the identifier. So the lexical grammars of Phytos and Haskells are not regular. What does that mean and why aren't they? Aside from separating tokens, distinguishing printful from printful spaces aren't used for much in most languages. So aside from separating tokens that we have discussed earlier, to separate that to identifier a printful and from printful, which is doesn't have a spaces, aren't used for much in languages. However, in a couple of dark corners, a space does affect how code is parsed in CoffeeScript, Ruby, and C preprocessor. Where and what effect does it have in each of those languages? A scanner here, like most, discards comments and white space since those aren't needed by the parser. Why might you want to write a scanner that does not discard those? So we discard the comments and white space. Why do you want something that a scanner that doesn't discard the white space? Maybe you want to track it so that you can compile, remove the dead space. What would it be useful for? Add support to lock scanner for C style slash asterisk dot 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 hashtag slash block comments. Make sure to handle new lines in them. Consider allowing them to nest. Is adding support for nesting more work than you expected? Why? So these are the challenges. So when adding support for lock scanner for C style block comments, the same way we implement the comments earlier, we will just handle this slash asterisk dot dot dot, and then allowing them to nest could be a little bit of work only, not a lot. So design note, implicit semicolons.